Potential energy of a system of charge. Consider 2-point charge Q1 and Q2 separated infinitely initially. We bring charge Q1 at position P1 in a reference frame chosen arbitrarily as shown. As there is no field, so work done in placing the charge Q1 at P1 is 0. Consider a point P at a distance rP1 from charge Q1. The potential at P due to Q1 is Vp1 equals to 1 by 4 pi epsilon naught Q1 by rP1. Let the charge Q2 is brought at P2 from infinity. Then from definition of potential difference, del W external infinity to P2 equals to Q2 into del V infinity to P2 or equals to Q2 into Vp2 minus V infinity. This implies del W external infinity to P2 equals to Q2 into Vp2 minus V21 minus V infinity 1 or Q2 into V21 since V infinity 1 equals to 0. V21 equals to potential at point 2 due to charge at 1. Hence, del W external infinity to P2 equals to 1 by 4 pi epsilon naught Q1 Q2 by R12. This work done is the potential energy of the two charge system. Hence, U12 equals to 1 by 4 pi epsilon naught Q1 Q2 by R12, where R12 is the distance between 2-point charge. Consider a third charge Q3 is brought from infinity to the point P3. Then work done in the field of charge Q1 equals to Q3 V31, where V31 is potential at point 3 due to charge Q1. This implies U13 equals to 1 by 4 pi epsilon naught Q1 Q3 R13, where V32 equals to potential at point P3 due to charge Q2. Now work done in the field of charge Q2 equals to V32 into Q3 equals to, this implies U23 equals to 1 by 4 pi epsilon naught Q2 Q3 by R23, where R23 is the distance between point 2 and 3, or equals to U23 equals to 1 by 4 pi epsilon naught Q2 Q3 by R23. Hence, potential energy of the three charge system equals to total work done in setting up the system. This implies U equals to U12 plus U23 plus U13 equals to 1 by 4 pi epsilon naught under bracket Q1 Q2 by R12 plus Q2 Q3 by R23 plus Q1 Q3 by R13. Potential energy in external field. Potential energy of a single charge. Consider the region where external electric field exists. The external electric field and corresponding external potential is varying from point to point. Consider a point P at a distance r from O arbitrarily chosen, where potential is given by VR vector. If a charge Q is placed at P, then potential energy of Q in external field will be equals to Q into VR. Second, potential energy of a system of two charge in an external field. Consider charge Q1 is brought firstly in external field at P1 and then Q2 is brought at P2 as shown in figure. The potential at P1 due to external field will be VR1. Hence, potential energy of Q1 in the external field at P1 equals to work done on Q1 against external field equals to V R1 Q1, equation 1. Now when Q2 is brought, work has to be done against external field and against the field due to charge Q1. Hence, work done on Q2 against the external field equals to Q2 into VR2, equation 2, where VR2 equals to potential at P2 due to external field. Work done on Q2 against the field due to Q1 equals to VR2 Q2 1 by 4 pi epsilon naught Q1 Q2 by R21, equation 3, where V21 R2 equals to potential at P2 due to charge Q1 and R21 equals to distance between Q1 and Q2. Thus, potential energy of the system equals to the total work done in assembling the configuration, which is equals to, this implies U equals to Q1 VR1 plus Q2 VR2 plus 1 by 4 pi epsilon naught Q1 Q2 by R21. Now example 2.1, which is given in book, can be solved with this equation as shown in figure. Now B, del W external delta U, del W external initial to final, delta U initial to final UF minus UI, or equals to U infinity minus UI equals to minus of UI, since U infinity equals to 0, where U infinity is the potential energy of system with infinite separation, equals to minus of minus 0.7 equals to 0.7 joule. Answer. Solution of part C. We have E equals to A into 1 by R square, where A is given 9 into 10 to the power of 5 coulomb per meter square. This implies E equals to minus dV by dr. This implies dV equals to minus E dr. This implies integration infinity dV infinity to R1 equals to minus of E dr integration infinity to R1 equals to minus infinity to R1 A into 1 by R square dr. This implies V R1 minus V infinity equals to minus A into under bracket minus 1 by R in the limit infinity to R1 equals to A into under bracket 1 by R1 minus 1 by infinity equals to 1 A by R1. This implies V R1 equals to A by R1. Similarly, V R2 equals to A by R2. Hence, U equals to Q1 V R1 plus Q2 V R2 plus Q1 Q2 4 pi epsilon naught R12 equals to Q1 A by R1 plus Q2 A by R2 plus Q1 Q2 4 pi epsilon naught R12. Putting all given values, we get finally the value of potential energy 49.3 joule. Answer.